Hello everyone, I'm Bindu Trikha, Assistant Professor, IMS Ghaziabad. Today in this video, we would be learning about multiplexers, how to design a multiplexer and what are its various functions. Multiplexers are the combinational circuits that are basically used for transmitting large number of information units over smaller output channels. Likewise, we have more than one input lines and we have one output line, and to select one of the input line we have a set of selectors. These selectors are basically used to select one of the input lines that behaves as the output for our particular multiplexer. In a multiplexer in general we have 2 to the power n input lines. If we have 2 to the power n input lines, that means we have n selection lines, because with n variables we have 2 to the power n possible combinations, and output line is 1. We have 4 to 1 multiplexer, 8 to 1 multiplexer, 16 to 1 multiplexer. Say I am having a 4 to 1 multiplexer. That means this multiplexer is having 4 input lines, 2 selection lines and 1 output line. Similarly, if I have 8 to 1 multiplexer, I would be having 8 input lines, 3 selection lines to select one of the 8 inputs and 1 output line. Now let us consider this 4 to 1 multiplexer. In this we have I0, I1, I2, I3 as the inputs and S0, S1 as the control selection lines. Basically, if S0, S1 is 0, 0, I0 would be selected as output. If it is 0, 1, I1 would be selected as output. If it is 1, 0, I2 would be selected as output, and if it is 1, 1, I3 would be selected as output. Here enable is also used in this particular multiplexer. It is used because enable acts as a main switch. If this enable is low, that means our multiplexer won't work. Whatever control inputs we give to the multiplexer, it won't work. But if enable is high, then only this multiplexer would be in working condition. Now here, if multiplexer is enabled and the corresponding values for S0, S1 are 0, 0, output would be I0, 0, 1, output would be I1, 1, 0, output is I2, and 1, 1, output is I3. Now putting this particular information in Boolean equation, we would be getting the equation for y, and then we would implement this y using AND gates and an OR gate. We have enable going to AND gate 1, I0 as an input to AND gate, S0 S0 selection line is going in an inverted form to AND gate, and S1 is also going as an inverted form to the AND gate. So here the input would be, enable would be 1, S1 0, not S0 0, and since these two S1 S0 are going through a NOT gate, passing through a NOT gate, the values would be inverted and 1 1 would be going to the circuit. Similarly, we have for second AND gate I1, S0 negated form, S1 direct form. For third AND gate we would be having enable I2, S0 in the direct form and S1 in the negated form. In the fourth AND gate we would be having enable I3, S1 in the direct form and S0 as well in the direct form. This is the circuit diagram for 4 to 1 multiplexer. Let's see how it is working. Now here, say enable is 1, S0 is 0 and S1 is 0. The input for AND gate would be I0, 1, 1, 1. The output would be I0. Because the output now depends on the value of I0, all the other inputs are 1. In second AND gate, the inputs are I1, 1, 0, 1. Since it is one input is 0, the output for AND gate would be 0. In third AND gate, it is I2 0 1 1. Now since one input is 0, output is 0. Similarly, in fourth AND gate, it is I3 0 0 1. Two inputs are 0, output would be 0. Now input for OR gate is I0 0 0. As far as an OR gate is concerned, the output for this OR gate would now depend on the value of I0. If it is 0, the output would be 0. If it is 1, the output would be 1. So the output comes out to be I0. Next we have the example for, say we have S0 0 and S1 as 1 and enable is also 1. The inputs for AND gates are as shown in the image. Here we have second AND gate with the output of I1 and all the other three AND gates as the output for have the output as 0. Now these output now acts as an input for the OR gate, and the final output of this particular multiplexer comes out to be I1. If we have the values as 1 0 1, we have these possible combinations 0 0 I2 0. Here third AND gate would be having an output of I2 that acts as an input for the OR gate. So y is equals to I2. Then we have 1 1 1. The inputs for first AND gate, second AND gate, third AND gate and fourth AND gate. Here the outputs are 0 0 0 I3. So for the OR gate, output depends on the value of I3. So y would be equal to I3. This is the functioning of a 4 to 1 multiplexer. Thank you.